Hey guys, please get out your note sheets for 8.4 special products. So we're going to look at two different special situations that may occur when you're multiplying binomials that you need to be aware of. And I have an example of what each of these may look like, and we're going to kind of break them apart first and see if we can figure anything out about them, and then we will talk about how you can actually solve these using shortcuts if needed. So this first example has 3x minus 1 times 3x plus 1, and if you use a method to multiply, you get 9x squared minus 3x plus 3x minus 1, which simplifies to the final answer of 9x squared minus 1. So what you want to think about for this kind of problem is what actually happens to those middle two terms is that they zero out because they have opposite signs with the same exact term. So when you add those, they're definitely going to create 0. And the other thing to think about is there a way that you can tell that this will happen from the original binomial? So if you look back at 3x minus 1 times 3x plus 1, is there a way that you think you could tell that those middle terms would zero out? And you can leave this blank for now and or write something in, because as we do more, you should be able to fill this part in. The second example would be something like 4x plus 1 times 4x plus 1. The more common way that you're going to see this written would be the quantity of 4x plus 1 squared. And what you need to recognize is that that really means that it's 4x plus 1 times itself. So when you multiply, you get 16x squared plus 4x plus 4x plus 1, which simplifies to the final answer of 16x squared plus 8x plus 1. And what you want to think about here is if you notice anything about the numbers in the original binomials and the numbers in the final answer that might be able to create some kind of shortcut. So the original numbers were the 4x and the 1, and then the final answer became 16x, 8x, and 1. And so maybe some of you are realizing something that they have in common. And if not, again, we can leave this blank, but as we start looking at some more examples, hopefully you'll be able to fill something in here, but we will talk about it later. So we have three different kinds of special products. It's really two, but we'll separate our first two here. So the first one says it's a square of sum, and you have an example of the quantity of x plus 5 squared. Again, please keep in mind that really means x plus 5 times itself, x plus 5. And if we actually did multiply, we would get x squared plus 10x plus 25. Second one's the square of a difference, so difference because of the minus sign. Quantity of x minus 6 squared would really be like x minus 6 times itself, which creates x squared minus 12x plus 36. And then our last one's a difference of squares. And so if you use a method to multiply these, you end up getting 4x squared minus 49 for those. Again, we'll start talking about more of these relationships here in a second of how we can find maybe shorter ways or ways to determine how these are special products. Okay, so what we're going to look at first is how to find the square of a sum or a difference. The rules and steps would really be the same. It's just one has a plus, one has a minus. So first thing we're going to look at is that what can help you solve these is you either write out the two binomials being squared, and then use distributed property, FOIL, or box methods. So this would be what you've already learned how to do. So that's definitely one possibility. I highly recommend this to people who are not good with shortcuts. Or the following quick trick is a way that you can also get this same answer. And so the quick trick really says that for any kind of square of sums or differences, what you can really do is square the first term. So we know even if we were to do FOIL or something like that, that would be x times x. But the shortcut says without writing it out, just square x, the first term. The middle step for your shortcut says to multiply both terms together and then double the product. So without writing this out, if we were to take these two terms and multiply them together, x times 6 is 6x, but then when we double that product, then we're going to end up with 12x. And then the last part of the shortcut says to take the second term and then square the second term. So again, without writing this out, we would take that second term 6 and square it, and that would be 6 squared, which is 36. So the final answer here would end up being x squared plus 12x plus 36. And again, you can write it out and just FOIL or box method or distributed property, and you're still going to get that answer. But for any kind of square of sums or differences, this would also work. So we'll take a look at three examples of sums here, and then we'll do squares of differences in a second. So again, you can either write it out, and I already have that shown on here, where I've extended and wrote out each of these to show that it's really two binomials multiplied by itself. Or you can use the the shortcut. So the shortcut would say take the first term and square it. So for example 1, that would be x squared. The middle rule would be taking the two terms and multiplying them. So x times 3 is 3x, and doubling it would be 6x. And then the last part of your answer is the second term squared, which would be 9. Now, if you think about why we're doing the doubling, it's because if you go through, and I'm going to use FOIL, and we have 3x for the outer terms and 3x for the inner terms, then we're basically taking 3x and doubling it to get 6x for that middle term when you're doing FOIL here. And that's why we can kind of just assume the shortcut would work for any kind of square of sums or squares of differences. So second example, we would take the first term and we would square it because we know it's going to be multiplied by itself, which is 4x squared. Because in FOIL, the outer and inner terms are really going to be 2x times 5 and another 2x times 5, we could just multiply that to get 10x plus 5, but then double it, which is 20x. And then the last term is just the last term times itself, so 5 times 5. And then your last example, we're going to take the first term and we're going to square it. And be careful, because when you square negative 4x in parentheses, it's going to become positive 16x squared, and you could see it here if you did FOIL. We're going to multiply those two together and double it, so that's going to be negative 12 doubled, which is negative 24x, and then multiply your last two terms, or square your last two terms, to get 9. So if we were to go back to the beginning of this on your note sheet where it says, do you notice anything about the original binomials and the numbers in the answer? Something that you can go ahead and write in now if you haven't already noticed it is that the first term is the first part of the binomial squared. The last term is the second term in the binomial squared, and then the middle term is basically what we're saying the shortcut is. It's basically those two multiplied and doubled. Okay, 3 more examples, and this time it's a square of differences, so same concept applies, it's just minus signs instead of plus signs in parentheses. So we're going to square the first term, which would be x squared in example 4. We're going to multiply these two together and double it. That's a negative 2x doubled, which is negative 4x. And then we're going to square the last number. Now again, because it's negative 2 times itself negative 2, and you could see that here in the FOIL, it becomes positive 4. Example 5, square the first term, 16x squared. Multiply the two terms together and double it. That's going to be negative 24x. Square the last term, because it's in parentheses, it becomes a positive 9. And then example 6, square the first term, in parentheses it becomes positive. Multiply the two terms together, that would be a positive 15x, doubled is 30x. Again, we double it because we have 2 of those when we do outer and inner and FOIL. And then square the last term because it's in parentheses, it becomes a positive. So something you might want to think about for all of these examples, and this will always be true for a square of sums or differences, the last number is always positive, has to be, because you get the last number from multiplying something by itself, and when you multiply a number by itself, it always creates a positive. So that's a way to identify answers that would be a square of a sum or difference. Okay, and the last kind of special product we're going to look at is when you have a difference of squares, and the answer is really what's describing it being a difference of squares. So again, with this one, you can either just multiply them as is using distributive, FOIL, or box method, or there is a kind of shortcut that we can generalize because all difference of squares will end up working out this way. So that shortcut would say that you can actually just multiply the first terms together. So in this case, that would be x times x, and x times x would be x squared. The other part of the shortcut says that you can just take the last two terms and multiply those together, so that in this case is positive 4 times negative 4, which is negative 16. And the last thing's kind of just a side note, because your answer actually is x squared minus 16. The middle terms will always cancel with a difference of squares, because if we were to do the two middle terms, it becomes negative 4x plus 4x, and that would equal 0. So that goes away. So this really becomes your ultimate final answer, x squared minus 16. So this one's a really, really quick way to do these. It's just multiply the first and multiply the last. You kind of skip the OI and FOIL if you use FOIL to simplify. So we've got a couple of these examples as well. Key to identifying these to use the shortcut would be to make sure you have the same two binomials, but they have opposite signs. So as you would think through or go through FOIL, you can say, hey, that's going to be 4x squared. This would become minus 8x plus 8x, so that cancels, so there's no middle term, and then minus 16. Example 2, I see the same two binomials, opposite signs, so really we can skip OI and FOIL and just do the first terms to get 9x squared and the last terms to get minus 4. And then number 3, you can do your first two terms to get 64x squared and your last two terms to get minus 36. If you're not good at shortcuts, again, you can do the full FOIL or box method or distributive here, but you should always get those middle terms to cancel when you start with two binomials with opposite signs. So if you need to add that back in into the very first thing we talked about earlier, how can you tell this will happen from the original binomials, that those middle terms cancel? It's when you have the same exact two binomials with opposite signs. Alright, so the next thing I want you guys to do is just practice identifying which one of these are special products. You have these on your note sheet, so you can go ahead and try and circle, and if you're using pen, you might want to hold off any of these that you think would be special products, and then you could press play whenever you're ready to check, and I'll give you what the answers should have been. You don't have to solve, you can just identify. Okay, so there should have been 5 correct answers. Letter A would be a square of differences, so you could rewrite it the way I have it shown there. B is no good, they're not the same binomials at all. C, no good, again, not the same binomials since you have a 4x versus a 1x. Letter D is good to go, that's a difference of squares, that same binomial with opposite signs. Letter E would be a square of sums, so that is good, and I have it rewritten the way you would most likely see it. F, no good, completely random, that's just two completely different binomials. And then G and H are both difference of squares since you have those same two binomials multiplied but with opposite signs. That was when the middle term would end up canceling. The last thing I'm going to have you guys do is practicing. It says to use the quick tricks on here, but you don't have to. If you want to just solve using any method you like for multiplying, you can. And you can press play for the final answers for each of these whenever you're ready to check them. Okay, so number 1 was a square of differences, so square the first term, multiply and double the middle term, and then square the last term to get x squared minus 12x plus 36. Your second one was a square of sums, so again, square the first term, 9p squared, multiply and double to get 24p in the middle, and then square the last term to get 16. Example 3 was a difference of squares, so it's just basically f and l, no OI, so it's x squared minus 121. Number 4, another difference of squares, you get 4x squared minus 9. Number 5 would be a square of differences, so square the first, multiply and double the middle term to get 16x squared minus 40x, and then square the last term to get plus 25. Number 6, another difference of squares, so multiply the first and last terms only, you get 81x squared minus y squared. Number 7, a square of sums gives you m squared plus 10m plus 25. Number 8 gives you 16a squared when you multiply the first times itself. Multiply and double for the middle gives you minus 24ab, and then your last term squared is 9b squared. And then last one is another difference of squares, which gives you 9 minus 25x squared. So hopefully you found these pretty easy. We will definitely practice more of these. They're not going to be on tests saying, hey, this is a special product. They're just going to be mixed in with other problems. So these shortcuts are really to help you do those. If you don't like them, just do regular multiplication and you should still get your answers. See you guys soon.